Your electricity bill is not high because you use too much power. It is high because your utility company has been charging you for power you never used. Power that was never delivered to your home, and power that disappeared silently inside your own walls before a single light ever turned on. Every month, for years. And the $4 device that proves it is sitting on the shelf of every hardware store in the country. The utility companies know it exists. They know exactly what it reveals. And they have spent 3 decades making sure you never think to pick one up. The phantom load draining your panel right now is not your television. It is not your refrigerator running overnight. It is not your air conditioner cycling through a hot afternoon. It is a combination of invisible consumption points that your utility meter counts and bills you for while your appliances sit completely switched off. The average household in North America is paying for 20 to 30% more electricity than it ever actually uses. That is not an estimate. That is a measured, documented, repeatable number that every electrical engineer in the country already knows. The $4 device is a plug-in energy monitor, also called a watt meter or a kilowatt meter. It plugs between your wall outlet and your appliance and shows you in real time exactly how many watts that device is consuming at every moment. What it reveals in the average household will make you set down whatever you are holding. Welcome to Professor Hassan's lab. If this kind of buried knowledge matters to you, hit subscribe and the bell. This is where we dig up what the industry tried to keep hidden forever. The story does not start in a utility boardroom or an energy regulator's office. It starts in 1882 on Pearl Street in Lower Manhattan, inside the world's first commercial electrical generating station built by Thomas Edison. Edison's direct current system was expensive to build, difficult to transmit over distances, and required a power station within roughly 1 mile of every customer it served. The infrastructure cost was staggering, but the billing model Edison established in that first station in 1882 became the template every utility company in the world still operates on today. Edison charged customers based on meter readings. The meter counted electrical flow passing through it. The customer paid for every unit counted. The problem Edison's engineers documented privately but never advertised publicly was that the meters of the 1880s were not precision instruments. They measured what passed through the line. They did not distinguish between power delivered to an appliance doing useful work and power lost to heat inside poorly insulated wiring, power factor inefficiency in motors, and resistance losses across long distribution cables. The customer was billed for all of it. A mechanical engineer named Charles Proteus Steinmetz, working for General Electric in the 1890s, published a detailed technical analysis of power factor losses in alternating current distribution systems. Steinmetz calculated that a significant portion of electrical current flowing through a standard residential circuit was reactive power, power that oscillated back and forth in the line, doing no useful work inside any appliance, but being counted by the utility meter as delivered electricity. He submitted his analysis to the National Electric Light Association in 1897 with a formal recommendation that residential meters be redesigned to measure only real power consumed by appliances rather than total current flow through the line. His recommendation was acknowledged, filed, and completely ignored by every utility company that reviewed it, because redesigning the billing system to charge customers only for power they actually used would have reduced revenue by an estimated 15 to 25% across every residential account in the country. That was not a change the industry was prepared to make in 1897. It is not a change the industry has made in 2024. The billing structure Steinmetz objected to over 125 years ago is still the billing structure on your monthly statement today. Now, here is what you need to understand because the science here is impossible to ignore. Every electrical appliance in your home operates on real power. Real power is measured in watts. Real power is what actually runs your refrigerator compressor, lights your bulbs, spins your washer drum, and heats your water. Real power is what you should be paying for, and only what you should be paying for. But your utility meter does not measure only real power. Your utility meter measures apparent power. Apparent power is measured in volt amperes. It includes both real power, doing useful work, and reactive power, oscillating uselessly in your wiring without powering anything. The gap between apparent power and real power is called power factor. A power factor of 1.0 means every unit of electricity your meter counts is doing real useful work in your home. A power factor of 0.7 means only 70% of what your meter counts is doing useful work. The remaining 30% is reactive oscillation, your meter records, and your utility bills you for. The average residential power factor in North America sits between 0.7 and 0.8. That number has been measured, published, and documented in electrical engineering literature for decades. It means the average household is being billed for 20 to 30% more electricity than any appliance in that home ever consumed in real useful power every month, every year, compounding across every household on every utility grid in the country. Now, pick up your $4 plug-in energy monitor. Plug it into any outlet, plug your television into the monitor. Switch the television off using the remote. Look at the watt reading on the monitor screen. The television is off. No picture, no sound. The watt reading is not 0. It reads between 2 and 8 watts depending on the model. Your television is consuming power continuously while switched off because it is maintaining its standby circuit, waiting for the remote control signal to tell it to turn on. This is called phantom load, or standby power consumption. Your utility meter is counting every watt of it every hour of every day and adding it to your monthly bill. Now walk to your microwave, plug in the monitor, read the watt display. The microwave is not running, the door is closed, the display clock is showing the time, the watt reading is between 3 and 7 watts. Your microwave is consuming power continuously to run its clock display and its touch panel control circuit every hour, every day, whether you ever use the microwave or not. Now check your cable box or streaming device, leave it in standby, read the watt display. Cable boxes and streaming devices in standby consume between 10 and 25 watts continuously because they are downloading program guides, receiving software updates, and maintaining network connections around the clock. A cable box consuming 15 watts in standby uses 131 kilowatt hours per year, doing nothing you ever asked it to do. At the average U.S. residential electricity rate, that is between $15 and $20 per year from one device in one outlet while you sleep. A 2015 study by the Natural Resources Defense Council measured phantom load consumption across 70,000 households in California. Their findings were not ambiguous. Devices in standby or idle mode consumed an average of 23% of total household electricity use. Nearly 1/4 of every electricity bill in those households was being paid for power consumed by devices doing absolutely nothing useful. The NRDC submitted their findings to the California Public Utilities Commission with a formal request for mandatory standby power limits on consumer electronics. The Consumer Electronics Association, funded by the manufacturers of the devices being measured, submitted counter-arguments to the same commission. The mandatory limits were not implemented. In 1992, the U.S. Department of Energy launched the Energy Star program with a stated mission of reducing energy consumption in consumer electronics and appliances. Energy Star certified products must meet specific efficiency standards, including limits on standby power consumption. The program was broadly praised when it launched. Then the lobbying began. By 2008, the Alliance for Telecommunications Industry Solutions, representing major cable providers and electronics manufacturers, successfully negotiated Energy Star standards for set-top boxes that allowed standby consumption of up to 15 watts per device. An independent engineering analysis published in IEEE Transactions on Consumer Electronics the same year demonstrated that the technology to achieve standby consumption below 1 watt in cable boxes already existed and could be implemented at a manufacturing cost increase of under $3 per unit. The standard was set at 15 watts anyway, because the cable companies billing customers for power consumed by their leased cable boxes had no financial incentive to reduce that consumption. Every watt their box consumed was a watt on your meter, on your bill, paid by you, and counted as delivered service by your utility company. Dr. Alan Meyer of Lawrence Berkeley National Laboratory, one of the world's leading researchers on standby power consumption, has been publishing documentation of this gap between available technology and implemented standards since the mid-1990s. His research has been cited in congressional testimony. His findings have been submitted to every major energy regulatory body in the United States. The standards have moved marginally. The billing structure has not moved at all, because the utility companies generating revenue from reactive power losses and phantom load consumption are the same companies that fund the industry associations advising the regulators who write the standards. That is not a conspiracy theory. That is the documented organizational structure of energy regulation in the United States, available in public records for anyone willing to read them. Now here is what to do with everything you just learned. This is the practical part. You need one thing: a plug-in energy monitor. The most widely available model is the P3 kilowatt electricity usage monitor. It is available at hardware stores, home improvement retailers, and online for between $4 and $25, depending on the model and features. The basic model that shows watts, kilowatt hours, and estimated monthly cost is all you need. You do not need the advanced models with wireless connectivity or data logging. The basic display does everything this protocol requires. Step 1. Start with the devices that are never truly switched off: your cable or satellite box, your gaming console, your printer, your router and modem, your microwave, your coffee maker with a digital display, your smart TV. Plug the monitor between the wall and each device one at a time. Record the watt reading and standby for each device. Do not skip any device with a digital display, an indicator light, or a remote control. Every one of them is drawing power continuously. Step 2. Add up your standby watt readings across all devices. Multiply the total watts by 24 to get daily watt hours. Divide by 1,000 to convert to kilowatt hours per day. Multiply by 30 to get monthly kilowatt hours from standby alone. Multiply that number by your electricity rate per kilowatt hour, which you will find on the first page of your utility bill. The resulting number is what you are paying every month for power consumed while your devices sit doing nothing you ask them to do. Step 3. For every device not requiring continuous network connection, install a smart power strip, or individual smart plugs that completely cut power when the device enters standby. Smart plugs that can be scheduled or controlled by a physical switch cost between $8 and $15 each. A smart power strip for an entertainment center costs between $25 and $35. These devices do not reduce the standby watt draw of your electronics. They eliminate standby draw entirely by cutting power at the outlet before the device ever reaches standby mode. The difference between a 15-watt standby draw and a true 0-watt cut is 131 kilowatt hours per year per device. Step 4 is the power factor layer that the utility industry most wants to keep off your radar entirely. A plug-in power factor correction capacitor, available for between $20 and $40, installs at your main electrical panel or at individual outlet points and reduces the reactive power oscillating in your home's wiring. It does not reduce real power consumed by your appliances. It reduces the gap between apparent power your meter counts and real power your appliances actually use. Independent testing by the Electric Power Research Institute documented average bill reductions of 8 to 12% in single-family homes after whole-house power factor correction devices were installed. At average U.S. residential electricity rates and average household consumption, that reduction represents between $120 and $200 per year, from a one-time device installation costing under $40. A project manager named Robert Salinas from Phoenix, Arizona, contacted us after completing a full household energy audit using a $12 plug-in watt meter across every device in his home. He found his standby. Devices were collectively consuming 340 watts continuously, 24 hours per day, 365 days per year. His phantom load alone accounted for $340 per year on his electricity bill. After installing smart strips on his entertainment center and home office, setting timers on his kitchen appliances, and adding a whole house power factor correction device at his panel, his monthly bill dropped by $47 in the first full billing cycle. His words to us: "I called my utility company every summer blaming the air conditioner. They sent technicians twice. Nobody ever told me my cable box and printer were running all night like small electric heaters. I found out with a $12 device in one afternoon." Total cost for his complete household audit and correction setup was under $80. His annual savings exceeded $560 in the first year of implementation. No solar panels, no efficiency upgrades, no new appliances, no contractor. One afternoon with a $4 device and the knowledge of what to look for. This knowledge did not disappear because it stopped being accurate. The physics of reactive power losses and standby consumption has not changed since Steinmetz documented it in 1897. The billing structure that profits from those losses has not changed either. The $4 device that makes both of them visible has been sitting on hardware store shelves for over 20 years. The utility companies know it is there. They know what it reveals when you plug it in and start reading the numbers on your own devices in your own home. What they counted on was that you never would. Steinmetz's 1897 analysis is still in the technical literature. The NRDC's 2015 household study is still indexed and publicly available. Dr. Meyer's standby power research is still cited and still being updated. The IEE engineering analysis of cable box efficiency standards is still published. None of it was hidden. None of it was classified or buried in an archive. It was simply written in the language of engineering journals and regulatory filings that no utility company ever had any reason to translate into plain language for you. We did not lose the knowledge that your electricity bill contains charges for power you never used. We just stopped asking what exactly those charges were for. But stopping is not the same as gone, and forgotten is not the same as erased. If this vault opens something for you, subscribe to Professor Hassan's lab and share this with one person who has called their utility company to complain about a high bill and been told to use less electricity. Every share puts this knowledge back in the hands of the people it always belonged to. The next vault opens soon, and what is inside is heavier than anything we have opened yet.